Okay, so if we have some array, it's some random numbers. Okay, we have our array of numbers. Okay. And if we wanted to sum this, so we want to return the sum of this, one of the ways of thinking about this, so let's put our array in here. 5, 6, and 4. We can think about this as, well, this is really, if we take the first element, is really that plus the sum of the remaining array. So 5, 6, and 4. Okay. And of course, then that is really just, you can get this idea that the sum of that is really just 5 plus the sum of the remaining array. Okay, so this time, rather than having a single number that's being shrunk every time. So in the example of the factorial, we took away 1 every time we had -1. In this way, we're actually taking a data structure and then operating on a smaller part of it every time. Okay, we still have something left. So then that is going to be the sum of 6 plus the sum of, and we're down to one element, 4. Okay. And then that is just 4. Okay, and we get this nice thing whenever we do it this way. Okay, this is super inefficient. Okay, this idea of copying or taking a smaller part of the array each time isn't the way you would want to normally do a sum algorithm. You would just simply iterate through and add up. But this is one way of basically reducing this problem. The divide and conquer is pretty bad compared to binary search because our divide and conquer is going to cost us the same number of elements that are in the array. We're going to split this n times, essentially. This is size 4, and you can see we split 1, 2, 3. Now we had the first one as well, 4 times. Okay, so the divide and conquer here isn't exactly the smartest in the world because it's basically, it becomes a linear solution. We have 4 function calls and we have 4 elements. So if 4 elements all of a sudden became 1024 elements, that would be the same number of times you would call the sum algorithm. Okay, but that's one way to think about it. We just simply take a smaller and smaller part of the array every time and add it on. And again, we have our base case here. We have nothing else to do. Our array length here at the end was 1, so we just can take that value. And then all of these calls, they have all been pushed onto the stack as we saw before. And once we hit that base case, then all those additions will actually be performed, and we should get the answer of 10, 15, 22, we hope. Okay, that's one way to think about the kind of dividing and conquering. And again, it's for sure not the most